All of the intervals and work we've been doing has been the first derivative test, which basically tells you was the original increasing or decreasing on that interval. And your point, or excuse me, your critical values or critical points were the only places that the original could change from increasing to decreasing. It didn't have to, but it could. Well, this is what's called concavity. That's what the second derivative will tell you. Basically, if the second derivative is positive, that's what greater than 0 means, then it's going to be what's called concave up. Concave up means basically it looks somewhat parabolic and it's opening up. Now, it doesn't have to be the whole thing. It could just be like this. You agree that's still opening up. Okay. One of the greatest examples of concavity is that parent graph for x to the third. Right about here, it switches over, correct? To the right over here, this one is concave up. Over here on the left, it's concave down, okay? Because it's basically less than 0, it'll make it concave down. If the second derivative is equal to 0, then you started with a line. And think about that. If your original was 2x, your first derivative is 2, and your second derivative is, do you agree that's the only way you're going to get 0 down there? Is if you started with a line? All right. So this one is kind of just a heads up, basically. Now here's how I remember these, and sometimes people get confused, but I remember the concavity this way, that if it's concave up, it was positive. If it's concave down, it was negative. Now don't think it's necessarily plus, plus, minus, minus in your intervals. It's just a way to remember if it's negative, it's concave down. If it's positive, it's concave up. Okay? And what you do is the exact same thing we did with the first derivative test, except you do it to the second derivative. You do all the exact same stuff. Really not much has changed. Okay? And so does everybody have enough from this one? Okay. So here I have given you a slightly harder. Now realize what this really means is the original is 6 over x squared plus 3, right? Now some of you may think that this has asymptotes. It does not. Because what's going to make the bottom 0? Give me a number that I can put in for x that's real that's going to make the bottom 0. I could give you positive and negative I squared of 3, but that's the only thing that's going to work, right? So this is actually continuous, which is kind of nice. I wasn't that neat. So what we have to do first, if we are checking for where is it concave up and down, that's all we want to know. What we have to do is get to the second derivative. Well, that was horrible, but do better than that when you're in. And so how am I going to take the derivative of this? I would do chain. Now the reason I didn't give it to you that way is probably what would you have said for taking the derivative? Probably would have said quotient, right? Would it still have worked? Yes. Okay. But I rewrote it this way so that we could do chain rule. And so remember, chain says to take that -1 times what's out front, so -6, right? X squared plus 3. Now don't forget this very important part. You got to take it down a power, right? And I'm going to get rid of this so it doesn't look like divide up there. But what do you get if I take that -1 down a power? -2. So those people that remember the power then normally forget the other part of chain rule. Yeah, you got to take the derivative of the inside yet. Remember, chain rule is basically somebody threw one function into another one, and it's at f of g of x kind of thing. And this is something, we could take the derivative again right away, but I would probably clean it up a little bit first. And so how could I possibly, clean this up a little bit? Yeah. Yes, I can take these two times each other. I can't really multiply into here. How come? Yeah, it's got a power to it, right? It's got that -2 power, and so exponents are to be done first. And so if I multiply that, I do get -12x. And what I'm going to do now is write that really where it would want to go, which is down here, and it is now happy. The unfortunate part is we could move that back up and do chain rule again, but it would be chain rule inside a product rule. Yes? Oh, I haven't gone that far yet, have I? Good question. The question, which was a very good one, is why do I have f double prime written when it's only f prime? Excellent. Yes, that's very poor penmanship, but that's okay. Well, that's only the first derivative. So we have two choices. It's either chain rule inside a product or chain rule inside a quotient. And whenever I have that option, believe it or not, I normally go with quotient. And based on how I saw you guys factoring out that not so nice stuff from earlier, I'd suggest that you stick with that too. So f double prime. And plus, it just helps us, review quotient rule, which says take the bottom and just write it down times the derivative of the top, negative 12, right? Minus, here's those big brackets, right? And then you write down the top times the derivative of the bottom. And how do you suppose we should take the derivative of the bottom? Yeah, chain rule. There was no way to get around that. And you wonder why we spend so much time taking derivatives. So we got 2x squared plus 3. Now I have to take that down a power, so to the first. And then derivative of the inside. We're not done. All over. Squared, which then has to be squared. Sure, you can just write it to the fourth if you want. Well, that didn't work very well, now did it? Oh well. We'll just have to stay on this page then and do it like this. All right. Well, we do have a lot of opportunities here. It depends on what you want to do. I know, well, I mean, you could be. If you can tell me where that equals 0 and what makes it undefined, we're good. So, if you can tell me that right now, let's just stop. Okay. 0 most definitely, 0 does not work. So, let's clean it up. Here's what I would do. You don't have to do this. But once again, when you're in this, they have a factor in common. The reason I did it this way is because now you can see it. When there were negative, you struggled with it, right? Had we done it the other way, there would have been some negatives involved. It would have made it harder. And so that's why I chose this way. So let's factor out the x squared plus 3, but unfortunately I can only factor out one of them. So if I factor one of them out of here, there's still one of them there. I could distribute that, but I'll choose not to. Well, I would be careful. Let's do minus, do this. This is now gone. Please don't leave it in there. Can you multiply all of that together? Yeah. It's more than 24, isn't it? 48. Well, I have a minus right there, so. Over x squared plus 3 to the fourth. Any questions where any of that came from? Yes, what's your question? So then ask a question. What stuff? Because I factored it out front. I factored this and one of those out. Because here's the minus. There were two terms on top. They were just really ugly looking. And I took what they had in common out. I could have taken the negative 12 with it as well. I thought that might have been too much. And so there's still one of them in there, and here it is. And then there's still the negative 12. And then this is gone now, so all of that multiplies together to be negative 48x squared. All right? And the bottom is squared squared, so it's the fourth. Yes. Yes?
Since you have an x squared plus 3 on top, you can't apply
Good try. You were really good, and you should have stopped. The statement was, seeing there is an x squared plus 3 on the top and an x squared plus 3 on the bottom. This one and, well, there's 4 of them really down there, right? But what operations right here is the important part? Multiplication. So then you can. And this becomes a 3. Now the question is, can I take this one and cross off another one? No, because there's minus. Okay. So, f double prime. Well, we've got, can I distribute this now? I was going to do it right away, but everybody okay with that? All right. Negative 12x squared minus 36 plus 48x squared all over yeah, we can combine stuff. Here's another example of where calculus is basically one-step calculus followed by about 15 steps of algebra. Okay, so I've been told that this is 36x squared minus 36 on top, all over x squared plus 3 to the third. Whew. So as you can see, sometimes second derivatives are loads of fun. Now, let's not forget what the problem was. This was a great review of quotient rule, chain rule, all that good stuff. But this is the second derivative test, which is where we are to find out where's it concave up and down. And so our job is to find some intervals. We have to find where can it change from concave up to down, and those are your critical points again, which are places where the second derivative will equal 0 or is undefined. Is this ever undefined? We mentioned that earlier, right? There's nothing I can put in there that's going to make this undefined. That's real. So that's good. So setting the bottom equal to 0 is done. Hopefully setting the top equal to 0 is very simple algebra for you. It is. You add the 36 over, right? 36x squared equals 36 divided by 36. X squared equals 1. Square root. X equals positive and negative 1. It is, but most of them aren't this hard. Real, normally. So, seeing our original is continuous, we don't have to worry about asymptotes. And so from negative infinity all the way to what? This thing's either got to be concave up or down. Negative 1. And then from negative 1 to what? It could possibly be the other one. Okay, but we know that whole time it's either concave up or down. And from 1 to infinity, we also know for that entire time it is either concave up or down. And how are we going to test? Yeah, pick a number. Where am I going to substitute that number into, though? The second derivative, seeing this is the second derivative test. So pick a number like, oh, I don't know, negative 10 sounds good. And or 0 sounds good, good answer. And then 10. So put negative 10 in there and in there. What is the end result? Positive or negative? It is positive because you square it both times, right? So, yeah. And the whole minus 36 really isn't going to affect it, right? So this interval has to be concave up, remember? Okay. Put in 0. It's a negative over positive, right? So it is. So that one is concave down. And put in 10. Positive. So it is concave up. Now if that's all they asked you, that's all you would have to say, and I think that's all it asks here. But I do have a graph for you. I will show you what it looks like quickly. And some of you are going to be a little upset when you see this one, but that's all right. Yes. Because there's, well, I did in my head. I set that equal to 0. You cube root both sides. Subtract 3. Square root. It's imaginary. Yeah, we did that before, and that's why I didn't do it. All right. Any questions on that? All right. Whoa. And here's the graph for everybody's amazement. Actually, I don't know the y values off the top of my head, but I can figure those out quick enough. Ooh, it's not much. So here's your -1. There's your +1. Does it change concavity? Yes. Boy, if I zoomed in, that would almost look like a bell-shaped curve.
Oh, stop that.
Yeah. Now, what did we do? We took the second derivative. Let's not lose focus here because the second derivative took so much work. Let's not lose what we did. Set the second derivative equal to, and found where it was. Undefined, which was nowhere. And we found concavity, which is from the second derivative test. Yes? No, that whole interval is concave up. Yes. Okay, very good question. Everybody's attention up here. It's not just -1 that is concave up. It's that entire interval is concave up. This entire interval from -1 to 1 is concave down. The entire interval from 1 to infinity is concave up. But notice, is 1 or -1 included in my intervals? Ooh, so those points could prove to be very important points. So for tomorrow, do these other two. Look at the second derivative of this one will be easier or harder. Oh, way easier. This second derivative, way easier. Okay. So do examples 2 and 3 for tomorrow along with number, what was it, 8 from graphing worksheet.